Let's work on some gas law problems, and we read through this problem. We are given measurements and we can use the units to determine which variables we're given. So this is a volume. And if you read this, it's a scenario where a gas is changing conditions. So you can use the combined gas law, or I'll just use the ideal gas law for all of these problems. So there's a volume 1 changes from, so that'll be P1. 2, that's our second pressure. And if the temperature does not change, that means it's constant, what will the new volume be? So we're looking for, the question is asking us to solve for V2. All right, so we have our, get this out of the way. We have the ideal gas law as PV equals nRT. And one thing you can do is put all the constants on one side. All right, so temperature is temperature does not change. That's a constant. R is a constant. Number of moles a constant. They're all constants here. So we can just write P1V1 is equal to P2V2, because this is not going to change. Before and after, whatever happens to this system of gases is going to remain constant. This is known as Boyle's law, by the way. All right, so let's just plug and play. Plug these numbers in. Actually, I'll rearrange this right now algebraically, so we can just plug the numbers in. All right. So it's asking us for V2. So V2, if we rewrite Boyle's law, is going to be P1V1 over P2. Or I just divided both sides by P2 to isolate V2. All right, so now we can plug our numbers in, and P1 is given to us as 105 kilopascals, and V1 is given to us as 2.50 liters, and the final pressure is 40.5 kilopascals. All right, let's punch these numbers in our calculator. 105 times 2.5 divided by 40.5, and our final answer is going to be 6.48. Now these kilopascals are going to cancel out, so we're left with liters. All right, 3 sig figs, because all our measurements have 3 significant figures.